Okay, write down the topic potential energy. Potential energy of a mass in gravitational field. So we discussed the previously we discussed the potential of the gravitational field. So today we have discussed about the potential energy of the mass when placed in gravitational field. Okay, okay, write down the topic. So what is the potential? Previously we discussed potential mean if I take the earth which having a mass capital M, and when I place I take the this kind of point P, it's located at r distance from the center of the earth. So what should be the potential of the this point? We know V equals minus G M over R. M means the mass of the earth, mass of the earth, and this one. How can we get that this equation? Using the integration. So we no need to memorize. The only case is the this formula should be memorized. So don't need we do not need to use the integration. So this is the equation. So the potential mean previously we discussed what is the potential mean. What mean by the potential? Potential mean the yes amount of work done. Potential is the amount of work done that should be done to get the unit mass m from infinity to this point. So this is the potential for the unit mass. The work done is the this one. Why it is minus? Because when we take the some unit mass to this point, also this earth or the this mass getting attract the unit mass. So previously we discussed. So that's why we are using the minus mark because this work done is the negative because this work done is done by the gravitation. Gravitation. Okay. So this is the potential. Potential. We discussed previously what is the potential is when we take the unit mass from the infinity to this point. The potential is the work done that should be done to get the unit mass to this point. So this is the potential. The the potential energy of a mass mean this is the potential. The potential energy of the mass is if I place the simple m mass to this point, the potential energy is m into v. M into v. This is like a theory. So M into V, potential energy is the mass into the potential. Okay, write down, write down. If capital V is the, if capital V is the, if capital V is the potential at a point, potential at a point, potential at a point in a gravitational field, in a gravitational field, in a gravitational field, the potential energy, write down, if capital V is the, if capital V is the potential at a point in a gravitational field, in a gravitational field, the potential energy of a unit mass, the potential energy of a unit mass placed at that point, placed at that point is okay. Write down potential energy, potential energy of mass equal mass into potential. Mass into potential. Write down. No need to draw this one. After writing that one, let's write this one. Okay, write down potential energy of the mass is mass into potential. Mass into potential. Okay, then write. Capital P is the capital P. Capital P is the point of point of distance simple r, distance simple r, distance simple r from distance simple r, distance simple r from the mass, from the mass, from the mass capital M, from the mass capital M, right. The potential at a P point, the potential at a P point is okay. Draw this one and write this one. Potential at that point is Vp equals minus Gm over R. Minus Gm over R. Minus Gm over R. Okay, draw this one. Potential at P point equals minus Gm over R. Okay. Okay. Then I take the simple m mass to this point. I take the simple m mass to this point. කියන්නේ මම mass එකක් අරගෙන මෙතන තියනවා. මේක තමයි potential. අපි mass එකක් place කරනවා. When place the simple m mass to point to P point. Okay. The potential energy of simple m mass equals m into Vp. Vp means the potential of this one. M into minus Gm over R. Okay. Minus Gmn over R. No need to worry about this one. Why? You know how can we get the potential? Potential එක ගන්න විදිය දන්නවනේ. Potential එක ගන්න විදිය දන්නවනම් කිලිම mass එකෙන් multiply කරපුවාම අපිට potential energy එනවා. So we can get the potential energy easily. Right? Okay, write down this one. Quickly. Quickly write that. Gravitation field is very easy rather than other things. Okay, write down. Okay. I think you have done. Okay. So what is the potential? Potential mean the work done which I have do when placing a unit mass to this point, right? Why it is minus? Because work done is the work done by the gravitation field, right? We want to do that one. So the potential is that one. So previously we discussed. So potential energy means the potential into the potential into the mass, right? Very easy. But you need to consider the minus sign. Minus sign. Okay. What is the unit of the potential energy? What is the unit of the potential energy? It is very easy, no? Unit of the potential energy mean joule. Joule. You know. Right. Write down units of potential energy equals joule. So tell me what is the place potential equals to the zero? What is the place potential equals to the zero? Previously we discussed. Potential mean the work done which I have to do when the mass placed from the infinity to the that point. So that is the work done. So what is the work done at infinity? Infinite, infinite to infinity. What is the potential? What is the potential? Potential equals to the zero. In infinity, potential equals to the zero. If I place the some kind of mass to the infinity, the potential at infinity is zero, equals zero. When I place some kind of mass to the infinity, the potential energy at infinity equals m into zero. That means zero. So you need to identify that part. So write down units of the potential energy is joule. Then write down uh, in infinity. In infinity, potential is zero. Potential is zero. Therefore, potential energy also zero. Potential energy also zero. Potential energy also zero. Okay, let's do some kind of problem. So tell me tell me potential is the vector or scalar. Potential කියලා කියන්නේ vector එකක්ද scalar එකක්ද? Potential කියලා කියන්නේ vector එකක්ද scalar එකක්ද? අපි දන්නවා මොකද්ද? Potential කියලා කියන්නේ scalar එකක්. So potential is scalar. So we no need to get an what? We no need to get an vector value of the vector. So if I take the potential of the some kind of point, we can take it easily as a summation. So let's do the problem. So I take this kind of mass system. This kind of mass system. So I place 5 kilogram, 2 kilogram, 6 kilogram, 1 kilogram. Okay. So problem is number one. This is root 2 meter low. So problem is calculate the potential or calculate the gravitational field intensity at 0 point. Calculate the gravitational field intensity at 0 point. Number 2. Calculate the gravitational potential at 4 point. Okay. Number 3. Calculate potential energy when place the 2 kilogram of mass to 0 point. Okay. Okay. Find out. Quickly give me the answer. Very answers are correct. So how can I find the gravitational field intensity? How can I find? So I will erase this one. Okay. How can I find? So first of all, I need to take the one gravitational field intensity. ඒ කියන්නේ මම එකක් හිතලා අනිත් ඒවා ගන්නවා. I take the gravitational field intensity of 1 kilogram to point O as point O මම මේක ගන්නවා G කියලා. G equals ඒ කියන්නේ මෙයාගෙන් එන gravitational field එක. So මෙන්න මේ පැත්තට G. G equals Gm over R square. So G mean G, take it as G. M mean 1 over R square mean we have to take the length of this one. So how can I find the distance of this one? So that's a small calculation. So I know this is root 2, this is root 2. So this is R and R. Somehow I have to get that one. So 2R square equals to what? Root 2 square plus root 2 square. So what is this Pythagoras theorem? Pythagoras theorem. 2R square equals to root 2 square plus root 2 square. So Pythagoras theorem. So this one is 4R square equals 2 plus 2. That means 4. 4R square. So this one means R square equals to 1, R equals 1 meter. So I can easily find out the R equals 1 meter. So this is R equals 1 meter. Length of this one is 1 meter. Length of this one is 1 meter. So it is very easy. Okay. Then what is the R square mean? 1 square. So answer is G. So the gravitational field intensity produced by the 1 kilogram to the point O equals to G. G means 6.67 into 10 to the power minus 11. Correct? Then I mark all the gravitational fields. All the gravitational field intensities I have to mark. Okay. So how can I mark? All the gravitational field intensity I have to mark. කොහොමද මම ඒක mark කරන්නේ? So I have to mark it G1. Okay. So this is G and this is 2G. G, 2G and to this 5G. Why? We have to multiply by. This is 6G. Okay. We have to multiply it. Right? Give me 1 second. Okay. So therefore, this is 6G. Why? We have to multiply it by 6. Why? 6 means the mass is 6. Therefore, 1 into 6. So we know මේක එක තිබ්බොත් එහෙම මේක 6ක් කියලා આવොත් එහෙම 6යි වැඩි කරන්න ඕනේ. මේක 5යි වැඩි කරන්න ඕනේ. මේක 2කින් වැඩි කරන්න ඕනේ. After that, we can get that O point. So 2G into 6G 4G. මේ පැත්තට G තියෙනවා මේ පැත්තට 5G තියෙනවා. එතකොට 4G. So we have to take the vector addition of this one. Okay. So I also can write it as like this 4 capital G into 4 capital G. I have to take the summation. So I know is 45 45. I can take directly it as what? එළිම අපිට ගන්න පුළුවන් නේද? The gravitational field intensity, resultant gravitational field intensity equals to what? 4G square plus 4G square root of this one. That means 4G root 2. How can it run? මෙයාගේ 4G square කියන එක එළියට ගත්තොත් එහෙම එතකොට මේකේ 4G කියලා එනවා. එතකොට 1 plus 1 කියන්නේ root 2. Root 2. Therefore, this is the answer. 4 into 6.67 into 10 to the power minus 11 into root 2. So, answer is this one. Answer is this one. So, what is the answer? Answer කියනවා 37.73 into 10 to the power minus 11. 37.73 into 10 to the power minus 11. N kg minus 1. N kg minus 1. Right? So, මම මේක දැම්මේ ටිකක් මතක් කරගන්න. Right? So, recap your knowledge. So, I only need the gravitational potential. So, how can I find the gravitational potential? Number 2, gravitational potential at the O point. We have to get summation, all the summations. Okay, all the summation. Okay. Then gravitational potential of the 1 kilogram. It is equal to what? G 1 kilogram over R. Right? Minus Gm over R. R means 1. Right? We know V equals Gm over R minus Gm over R. That is a formula. We have to use that. Then we have to add then this one minus G 6 into R plus minus G 2 into R. plus minus G pi into R. Okay. Therefore, G minus 1 minus 6 minus 2 minus 5. It's very easy. Huh? Very easy. G and then 6, 9 and 9 to 5 again minus 40. Am I correct? Yes. 6.67 into 10 to the power minus 11 into 14. So this is the answer. This is the answer. Yes, I think 6.67 into 10 to the power minus 11. Mm, 0.9 6.67 into 14 93.38 into 10 to the power minus 11. What is the answer? Joule kg minus 1. Right? This is the answer. So this is minus. This is the potential. This is the potential. So when I take the 2 kilograms to this point on 2 kilogram method में place करते हैं ना 2 kilogram method के लिए place करते हैं ना method दिया potential है में therefore potential energy of 2 kilogram equals mass into the potential. Mass mean 2, potential 93.38 into 10 to the power minus 11. Joule kg minus 1. So this is the answer. So here then 2 into 93.38 in 1.86 into 10 to the power minus 9 joule. This is kilogram. Therefore, answer is this one. So I think your answer is correct. Okay. Oh, Hari. Uttara Hari. Mother. Amen. First one, we only have to take the intensity of the 1 kilogram. So මේ 1 kilogram ගේ intensity එක ගත්තොත් එහෙම ඒකෙන් අපිට ලේසියෙන් හොයන්න පුළුවන් gm over r square නේ. එතකොට gm කියලා කියන්නේ m කියලා කියන්නේ 1 kilogram then r කියලා කියන්නේ 1 meter. ඊට පස්සේ gm over r square එතකොට g කියලා එනවා. ඊට පස්සේ අපි මේ gravitation field එක මාක් කරනවා g කියලා. හරි. පළවෙනි කේස් එකේදී හරි. අපි g කියලා මාක් කරනවා. එතකොට එන්නේ මෙහෙම හරි පළවෙනි කේස් එකේදී මෙන්න මෙහෙම g කියලා මාක් කරනවා. මම ඔය කලින් ඒවා මතක් කරන්න තමයි දුන්නේ. එතකොට මෙතන 2g කියලා මාක් වෙනවා. ඇයි? මෙයාගේ මෑස් එක දෙකක් වැඩිනේ මෙයාට වඩා එහෙනම් 2g කියලා මාක් කරනවා. නැත්නම් ඉතින් මේක කෙලිම g කියලා තියෙන හින්දා අපි ඒක හොයාගත්තේ හින්දා ඕනනම් මේක කැපිටල් g කියලා මාක් කරන්න පුළුවන්. එතකොට මෙතන 5g වෙනවා. මෙතන 6g වෙනවා. අන්තිමේදී ඔක්කොම ගත්තා මේ පැත්ත 2g තියලා මේ පැත්ත 6g තියලා therefore we have to take the 4g into this direction. So because 6g and 2g cancel out this one, so we have to take the 4g. Then this is we have to take the 4g. Therefore 4g in this direction. Therefore we have to take this vector summation of this one. Vector summation, how can we get? There is a 90 degree. So if we can easily find the vector summation. So 4g. Therefore, vector summation is the 4g square plus 4g square. That means 4g into root 2. 4g into root 2. That's why it's very easy. Megalis. Okay, write down another problem. Draw this one. Draw this one. Then I will write number 1. Find out the gravitational field intensity at point O. Number 2, find the gravitational potential at O point. Calculate the acceleration when place 5 kilogram of mass on O point. Number 4, find the potential energy when placing 5 kilogram of mass on O point. Okay, do this one. G equals to 6.678 to 10 to the power minus 6. It is very easy problem. Right? It's very easy problem. Do the so find out this one. Now 1, 2, 3, 4. Quickly write down and find. So first of all, we have to get the gravitational field intensity. So how can I find the gravitational field intensity? Gravitational field intensity I can find when I use in when I can find taking the this one. So then මෙතන තියෙන gravitational field intensity එක G1 කියලා ගත්තොත් ඒකම නේද මේ පැත්තට තියෙන gravitational field intensity එක. Why? They both are same masses and with same distance. So gravitational fields are getting cancelled out. Only the gravitational fields acts upward. So number 1, Gr equals Gm over R square 6.67 into 10 to the power minus 11. M mean 5 kilogram. Very easy. 5 over R mean 5 square. So this is the answer. 1.3 6 into 10 to the power minus 11. N kg minus 1. What is the direction? Direction upwards. උඩට තියෙන gravitational field intensity එක තියෙන උඩට. Right? Why? Because the yes, I think your answer is 1.87. because gravitational fields are same to 9 kilogram and 9 kilograms. So both are getting cancelled out. Both are getting cancelled out. So this is the answer. So 1.8884, no? 4, yes, 4. 4 into 10 to the power minus 11. So number 2, find the gravitational potential. So V O. Gravitational potential mean I know GMOR, no? G, I take this one, G 9 kilogram, 9 kilogram over R mean 12, right? Plus G 9 kilogram over R mean 12. Okay. Then plus G 5 kilogram over R mean 5. So we have to get that one. How can we get that? Minus G 9 over 12 into 2 minus G 5 over 5. 5 to 5 cancel out, minus G remain. So this one is 6. So I need to cancel out this one 2. So minus 3G over 2 minus G. So minus 5G over 2. This is the gravitational potential. Minus 5 over 2, 6.67 into 10 to the power minus 11. Right? Joule kg minus 1. So this is the answer. So answer is 1.668 into 10 to the power minus 10. Minus 10 joule kg minus 1. So is this? Yes. Yes, this is the answer. So when I get in the number 3, what is the acceleration? So what is the acceleration? I think these are correct. So what is the acceleration? So when I place the some kind of mass at point O, so it get accelerated. Why? There is a when I place this mass, there is a gravitational intensity acts to the upper direction. Therefore, it create a force. Force mean F equals mg. You know, when there is a gravitational field, I take an Earth. So Earth, there is a gravitational field. G naught equals 10 nkg minus 1. When I place some kind of mass, therefore F equals m g naught. So I can tell this is the gravitational force. Gravitational force when there is a gravitational field. So there is a gravitational force. So I have to find what is the gravitational force. Then I have to find the gravitational acceleration. So I write before the race 1.334 into 10 to the power minus 11 nkg minus 1. So V naught equals to 1.668 minus 10 to the power minus 10. It's minus 2. So these are the data. So when I place some kind of mass in the O point, there is acceleration acts on the mass, right? Okay. what kind of acceleration? What kind of acceleration? So the force F equals mg. So I apply F equals ma to mass upward. So F equals ma, mg equals ma, right? There is a force. We don't need to find the entire force again. Why? We know this kind of theory. F equals mg. So m to m also cancel out. Therefore, A is also equal to G, right? Therefore, A equals to 1.334 into 10 to the power minus 11 nkg minus 1. Okay? Okay? So, these are the previous one. You need to practice very well. So, number 4, this is number third. So, gravitational acceleration and the gravitational field intensity also same because of this. Because we are taking the gravitational acceleration as the 10 ms minus 2. So, gravitational intensity as 10 nkg minus 1. Both are same. Why? Because of this. When you apply F equals ma to downward direction, our mass is acting as a weight, mg. Therefore, when we apply the F equals ma to our body, so there is a acceleration act on the our body equal to the gravitational field intensity. කියන්නේ G කියලා කියන්නේ 10 10 nkg minus 1 වලින් කියන්නත් පුළුවන් 10 ms minus 2 කියලා කියන්නේ gravitational acceleration එක ඉන්නේ field intensity එක එහෙම තියෙන හින්දා, right? So this is the answer. Okay? So fourth one, find the potential energy when placing the 5 kilogram on opposite side, right? Potential energy. What is the potential energy? Mass into potential. Mass mean 5 kilogram. Potential mean potential. This one 1.668 into 10 to the power minus 10. Right? This is joule kg minus 1. So this is kilogram. Then mass is coming from joule. 5 into 1.668 into 10 to the power minus 10 joule. So you need to find this one. What is the answer? 8.34 into 10 to the power minus 10. 8.34 into 10 to the power minus 10. This is the answer. Okay? Yes, your final answer is correct, but the previous answers are you need to. So, is there any problem? I think clear now. Okay, write down the topic. Work done. Work done. Right. So, I take the earth which having the radius capital R, and I have to move some kind of the mass from B to A, right? Therefore, the distance this to this center is symbol R, and I take it as H. Okay. So this is the Earth. So I have to move some kind of the mass from A to B or B to A. Right? Okay, write down before that. Writing that one. To move a mass from one point to another, write down the topic work done. Then write down to move a mass from one point to another point, another point, another point. In gravitational field, in gravitational field, in gravitational field, the work done must be the work done must be equal to equal the work done must be equal to the increasement of potential energy, increasement of potential energy, increasement of potential energy of a mass, increasement of potential energy of a mass. I had moved M mass to P to A. When moving simple M mass to A point to B. So the B point to A, B point to A. So therefore, work done equals to what? Work done equals to the change of the potential energy. As a conservation of the energy, we can tell work done equals to the potential energy difference. PEA, potential energy difference, right? Delta PE. This the kind of the conservation of energy, right? PE mean the potential energy is higher in the A. So I write PEA minus PEB. Okay. Then so PEA mean M into BA minus M into BB. Right? You know, if there is a potential of this A point is PA, then I transfer the mass that point. The potential energy is M into BA, then M into BB, then M into BA minus BB, M into BAB. So this is the work done. So this is the work done. So let's this is the work done. Okay. Okay, write down this one. First, write down this one. But in the mechanics, we know what is the work done. We should have to do when when placing the mass from this end to this end, this point to this end. When I transfer, there is a potential energy gain. Therefore, the work done equals to the potential energy gain. But in that time, we are discussing potential energy equals to increasement of potential energy equals to mgh. Right? In the mechanics, you know, increasement of the potential energy equals to mgh. So let's see, is that correct or not? Okay. Before that, write out this one. Okay. Then I will take that one. So in the mechanics, delta V equals to mgh, right? Let's see, is that correct? Let's see, is that correct? Okay. Work done equals to PEA minus PEB. Okay. PEA means minus G M over this one, no? This one. R minus GM over what? මෙතන දැන් potential energy එක කියලා කියන්නේ mass එක මෙතන place කරාට පස්සේ මෙතන තියෙන mass එක into potential energy. potential එක අපිට ගන්න පුළුවන් නේ -gm over ඒ සමහරට පැටලෙනවා නම් මම ඒක ආයෙත් ඒව දාන්නම්. අපිට යනකොට mass into VA mass into VB mass into minus GM over R mass into P වල තියෙන්නේ minus GM over capital R. So when I simplify that one, minus GMM over R minus GMM over R. So minus to minus cancel out and it gets plus. Okay. Therefore, I can write GMM over R plus GMM over R. Okay. Then I take the equal terms GMM. So I can find 1 over R minus 1 over R. Okay. අපි බලන්නේ දැන් mechanics වල කරපු එක මේකෙත් හරිද කියලා. මේකෙත් තියෙන හරියන්නේ නැපාය. ඒ කියන්නේ මෙහෙම කරද්දි වැරදුනොත් ඒ mechanics වල ඉගෙන ගත්ත එක වැරදිද? MGH කියලා ඉගෙන ගත්තේ. අන්න ඒක. Therefore GMM over R minus R. I take as common. R minus R කියන්නේ මොකක්ද? R වලින් R අඩු කරොත් එහෙම H එන්නේ නේද? එහෙනම් එනවා GMM R කියලා කියන්නේ මොකක්ද? R equals to R plus H. R කියලා කියන්නේ R plus H නම් එහෙනම් R plus H නම් minus R වුණොත් එහෙම මේ H විතරයි ඉතුරු වෙන්නේ. හරිද? එතකොට අපිට එනවා GM R into R into M into H. හරිද? මම දැන් මේ MGH කියන එක හරියද කියලා බලන්න යන්නේ. හැබැයි අපි දන්නවා මේ R කියලා කියන්නේ දැන් හිතන්න ලොකු තැනකට අපි දැන් mechanics වල අපි ඉගෙන ගත්ත එකේදී ලොකු තැනකට උස්සලා තියන්නේ නැහැ. We are only taking the some mass to a 20 meter, 40 meter, like that. Therefore, there is no huge difference between the simple R and capital R. Why I am telling like that? දැන් මම මේක අරගෙන යන්නේ නැහනේ. මේ earth එකේ radius එක ගන්නට වගේ. earth එකේ radius එක කීයද? 6400 kilometers. එච්චර දුරක් ගෙනියන්නේ නැහනේ මම. හරිද? එතකොට මම ගෙනියන්නේ 1 kilometer ගෙනිච්චත් මේකේ ලොකු කේස් එකක් නෑ. Why? R and R are approximately equal. R and capital R are approximately equals because capital R is equals to 6400 kilometers. So why 6400 kilometers ඒ කියන්නේ ගොඩාක් ලොකුයි මේ earth එකේ radius එක. එතකොට අපි මේ ගෙනියන R කියලා කියන්නේ පොඩි එක්කනේ. හරි 2 kilometers වගේ. හරිද මේක ඇවිල්ලා මේකට ළඟයි. හරිද මේ ගෙනියන උස ගොඩක් පොඩි හින්දා R and R approximately equal. Therefore work done GM over r square into m into h. So I can write, I take a work done W equals to Gm over r square mean what? The gravitational field intensity near the earth. G naught m h. එහෙනම් mg not h. work done කියලා කියන්නේ මොකද g naught කියලා කියන්නේ? g naught කියලා කියන්නේ gm over r square gravitational field intensity near the earth. Normally g naught කියලා කියන්නේ approximately equal to 10 mkg minus 1. මතකයිනේ? එහෙනම් mechanics වල කියන එක හරිනේ. So mechanics, in the mechanics we discuss that one. This is correct. Okay. Write down this one also. මේ work done එක හරිද කියලා බලන්න තමයි අපි ඔය වැඩේ කරේ. හරි? අපි මොකද කරේ? Only potential energy minus. So potential energy of the A minus potential energy of the B. Then m into VA minus m into VB. So I calculated to total. Then I get like this. Therefore, the work done equals to this one. Okay. Then I get this one. Okay. Write down this one.
Okay. ඔක තමයි කියන්නේ work done එක කියලා කියන්නේ. work done එක කියලා කියන්නේ ඔන්න ඔකට තමයි. right? එතකොට අර අපි mechanics වල කතා කරපු එක මෙතනදී හරියනවා. ඒ විදිහටම තමයි. but work done එක, so work done is depend on the path. Is that depend on the path? No. Why? When we are taking the mass into the another way and getting to the A, in all the cases we have to done work done similar to the previous one. So work done not depend on the path, only depend on the locations. Okay, write down it as the work done does not depends with the work done does not depend with the work done does not depend with the path of moving mass, the path of moving mass. Therefore, the field is called the gravitational field is called uniform force field. Uniform force field. Right. Then write down the topic. Uniform force field කියලා කියන්නේ හැම පැත්තටම uniformly force එක act කරනවා. Right? එතකොට අපිට normally ගත්තොත් එහෙම අර work done එක path එකේ depend වෙන්නේ නැහැ. ඕනේ path එකකින් ගියත් work done එක එකයි. Okay. Write down the topic. The potential energy of mass system or system of mass. Write down topic. The potential energy of mass system. The potential energy of mass system. Okay. To calculate the potential energy of the mass system, how can we calculate? So, if there is a mass m and simple m locate like this, so potential energy of the system equals to what? Potential energy of the system equals minus g m m over r. Why it's still like that? So there is some kind of the masses in the gravitation in the space. They are producing some gravitations. They are producing some gravitation fields. දැන් earth එක තැනක තියෙන හින්දානේ අපිට gravitation එක හම්බ වෙන්නේ. අපේ mass එකයි earth එකයි අතර තියෙන gravitational energy එක. Right? This is the energy of the mass system. Energy of the mass system. So likewise, when I take in the triangle, මම triangle එකක් ගත්තොත් එහෙම මෙතන m1 මෙන්න මේව triangle එකක් ගත්තොත් m2 m3 කියලා r1 r2 r3. So this potential energy of this system should I have to take m1 producing the gravitational field to this one and this one. So I have to separately taking the values. When I take in the m1, the gravitational field produced by the m3 and m2 should be calculated. Should be calculated. Likewise, we have to take all the gravitational field, right? Okay, write down the topic, the potential energy of the mass system. Then write down the total potential energy of the mass system can be taken can be taken can be taken can be taken the total potential of energy of the mass system can be taken as the summation of all the potential energy between them, as the summation of all the potential energy between them, as the summation of all the potential energy between them. Okay, as summation of all the potential energy between them. I have to take it separately. This is okay. Why? There is no huge case to this one. But when I take in when I take in this system, I only have to compare the pairs, right? So PE total මේක අපිට මේ වෙන වෙනම කට්ටියව කන්සිඩර් කරලා ගත්තා නම් ලේසි. හරිද? M1 and M2 I will consider M1 and M2. M1 produced gravitational field to M2. Okay. Minus G M1 over R1 into M2. This is number 1. Then plus the M3 also produced the gravitational field to M2. I also take that one. Minus G M3 over R2 produced to M2 plus what? I don't have any space, but that's why I take it like this. Also, I can use another space also. I will take this one. Then it PE total. I consider M1 and M2. M1 produce කරන gravitational field එක M1 over R1. එතකොට එයාගේ තියෙන්නේ M2. ඔන්න එකක් ගන්නවා. M1 ප්‍රොඩියුස් කරන මෙයාගේ ග්‍රැවිටේෂන් ෆීල්ඩ් එකට M2 ප්ලේස් කරපුවාම මෙහෙම එකක් එනවා. ආයෙ මේ M2 ප්ලේස් වෙලා තියෙනවා M3 කියන එක්කෙනාගේ ග්‍රැවිටේෂන් ෆීල්ඩ් එකට. එහෙනම් -G M3 over R2. එතන ඉන්නේ M2. right? ඒක හරි. මම මෙතෙන්ට ගියොත් එහෙම M3 කියන එක්කෙනා ප්‍රොඩියුස් කරන ග්‍රැවිටේෂන් ෆීල්ඩ් එකක්. He is producing the M3 is producing gravitational field to M1. right? Therefore plus minus G M3 producing gravitational field, the distance is R3 into M1. වෙන වෙනම ගත්තා අපි මෙයයි තුනයි. right? Only these are the pairs. So I can take it as minus G M1 M2 over R1 plus M3 M2 over R2 M3 M1 over R3. Okay, this is potential energy totally, right? Total potential energy. Okay, then take the potential energy of this system. This system, take the potential total energy. How can I get මේ වගේ එකක potential energy එකේ total එක ගන්න කොහොමද? මේ වෙන වෙනම ගන්න ඕනේ. try එකක් දෙන්න බලන්න ටක් කරලා. ඔක්කොම මේ ටික දාගන්න ටක් කරලා. මේ මෙයාගේ එක ඈ. So there is no space in that one. That's why I written. Okay, take this. I only have to consider total PE total equals to minus G M1 over R1 into M2 plus minus G M2 M4 over R2 into M2, right? Likewise, I have to take. Then I have to consider this one plus G M4 over R3 into M3 minus then plus minus G M1 over R4 into M3. Likewise, we have to take. We only need this. This is too much, but we only need this one. Like triangle එක වගේ එන්න පුළුවන්. මේක නම් ගොඩක් ඕනේ නැහැ ඉතින්. හරි? Right. Example එකක් දාන්න. Right. Example එකක් ටක් කරලා කරන්න. Okay, write down this one. Write down this one. You have to find what is the gravitational potential at the O point, gravitational field intensity, gravitational potential number 1 gravitational field intensity at point O. Number 2 gravitational potential at point O. Number 3 find the potential energy of the system, right? Of the system. Okay, quickly find out. Right. So it's first one like the previous one. ඒක පළවෙනි එක නම් බේසි. So gravitational field intensity at the point O කියලා කියන්නේ මොකද්ද? So gravitational field මේ පැත්තටත් තියෙනවා මේ පැත්තටත් තියෙනවා but same නේ. G1 කියලා දැම්මොත් ඒක same cancel out වෙනවානේ. මෙයාට මේ පැත්තට තියෙන එක නෑ මෙයාට මේ පැත්තට තියෙන එක නෑ cancel out වෙනවා. මේ පැත්තට තියෙනවා. තියෙනවා. ඒක විතරයි තියෙන්නේ. එහෙනම් මෙයාගේ මේක විතරයි තියෙන්නේ. හරිද? ඇයි මේක මෙයාගේ mass එකයි මෙයාගේ mass එකයි same distance දෙකක් same එහෙනම් gravitational field intensity same. හැබැයි මෙයාගේ තියෙනවා මේ පැත්තනේ. So first one answer for first one, what is the gravitational field intensity at point O mean so this is the point O. So only gravitational field intensity getting from the 4 kilogram. So what is the length? We know 3 meters, no? Why? Pythagoras theorem. Pythagoras theorem වල දන්නවනේ. මේක 3 meter වෙන්නේ කොහමද? 4 meter, 3 meter වුණොත් එහෙම 5 meter වෙනවානේ. Right. So this is 3 meter. So then gravitational intensity of this one is gm over r square. gm over r square. G naught equals G means 6.67 into 10 to the power minus 11. M means the 4 kilogram. R square means the 3 square. So this is the answer. What is the value? Two point 964 into 10 to the power minus 11 n kg minus 1. So number 2, gravitational potential at point O. Then I can find VO equals to minus G m mean 5 over r square mean 4 square plus minus G m over r square mean 4 square plus minus G m over r square mean 3 square. So what is the value? Minus G is common. 5 over 16 plus, sorry, not square, no? Square 9. V කියලා කියන්නේ GMO minus GMO R. Sorry, right. 5 over 4 plus 4 over 3. එතකොට minus g 5 into 5 කියලා කියන්නේ 10 10 10 over 4 4 over 3. Therefore minus g I have to take the common 12. So 30 plus 60. So this is the answer. Minus g 6 4 over 12. So this is the answer. 6.67 into 10 to the power minus 11. 46 over 12. So what is the answer? 6.67 into 25.57. 25.57 into 10 to the power minus 11 joule kg minus 1. Right? Is that okay? Okay. Then I no need to do this one. Why? This is previous one. No? I only need this one. The potential energy of the system. I only need that one. So how can I find the potential energy of the system? Potential energy of the system, how can I find? So I need to take the separately pairs and take the summation of the potential energy. So that means I need to take potential energy system equals to minus G 5 producing potential 5 producing gravitational potential to the 4 and 4 is located in that gravitational potential. Like that I can take pairs. So minus G 5 over 5 into 4 plus minus G I produce this one 5, the distance is 8, value is 5 plus minus G I produce in the gravitational potential 5 over 5 over 4. So this is the value. Okay. This and this cancel out, this and this cancel out. So minus 4G minus 25G over 8 minus 4G. That means minus 8G 25G over 8. So I can take it as the 64 plus 25 over 8G 9 8 89 over 8G, that is minus. So this is the answer. Answer is 74.2 into 10 to the power minus 11 joule. Okay. I think it's clear. This is the potential energy of the system of mass. Okay.